In this video, I want to talk about the 3 laws of thermodynamics and what that means for us when we're talking about chemical reactions. So the first law, which we've seen quite a bit, not necessarily by calling it the first law of thermodynamics, but the first law is basically the conservation of energy law. Okay, so that means that energy is not created nor destroyed. So that means that if we're dealing with a reaction or process, like we have heat transfer, something loses heat, something else gains heat. If we're dealing with a reaction and we have a high potential energy for our reactants and at a low potential energy for our products, well, that difference of energy has got to go into something. So that could either be through work or by the release of heat. Okay, so we've seen the applications of the first law of thermodynamics quite a bit so far in our reactions and the processes that we looked at, especially related to heat exchange. The second one is dealing with a spontaneous reaction. So for a spontaneous process, okay, remember a spontaneous process, something that happens without us having to add energy into it continuously, right? It just goes by itself, okay? For a spontaneous process, the entropy of the universe, okay, so we call this the change in entropy of the universe, is always going to increase or greater than 0, okay? And so our entropy of our universe is built up in 2 things, right? So we can think about that as the entropy of our system and the entropy of the surroundings. So this doesn't necessarily mean that the entropy of our system has to increase. It just means that both of these added together, the total entropy overall must increase when we have a spontaneous process. Okay, that's kind of a driving force for a spontaneous process to occur. The third law of thermodynamics deals with entropy again, okay? And the third law of thermodynamics says that at temperature equals 0 Kelvin, okay, so absolute 0, the entropy of a solid, okay, at that temperature is equal to 0 as well. Okay, so if we're dealing with the entropy of a perfectly ordered crystalline state, which would be a solid at 0 Kelvin, the entropy of that state would be 0. Okay, and we would have 0 energy to distribute among the molecules, and so therefore there would be only one way really to distribute that energy, and therefore our entropy would be 0. Now, what is a consequence for this? Well, that means that we can actually measure the entropy of each substance. Okay, so we're not going to talk about the entropy of formation of a substance. We can actually say the standard entropy of calcium chloride is a specified value. Okay, and we'll notice that the entropy or standard entropy of a substance, remember standard as standard conditions, is going to be greater than 0, right? Because if the baseline is 0, anything above 0 Kelvin is going to increase in entropy and have a higher entropy. Okay, so this is our 3 laws of thermodynamics that we're going to use to predict spontaneity, deal with this idea of entropy, and we've already used quite a bit dealing with this idea of energy transfer. So I just wanted to give you a little bit of an overview of these 3 laws, and the next couple videos in the class we're going to talk about some applications specifically of Law 2 and Law 3.